Okay, so now we want to take a look at how choices are made. And in looking at consumer choice, what we're trying to understand here is notions where people are making money through or making choices based on the fact that they face limited money. We know that that exists, but we want to understand first how the person is becoming happy. And again, the term that we're using for individuals becoming happy is utility. So let's start out first with this notion that happiness, the word for happiness that we are going to use is utility. Now, this utility word that we use here is that utility is a number. So in essence, we're saying that utility equals 60, or in some sense saying that the happiness equals 60. Now, on some level, that doesn't really make any sense, because what does it mean to be happy 60, right? I mean, the number doesn't indicate anything. But what if I told you another individual had happiness of 80? What we would be able to say is that this person, U2, is happier than the first person who has 60. So, this is the utility number that we're using is a ordinal number, meaning it's rank ordered. This person is happier than this person. But it is not the case that this person is 20 units happier than this person, because the numbers don't mean anything across different individuals. All that we know is that bigger numbers, person's happier. Smaller numbers, person's less happy. Okay. Now, total utility, right? That would be total happiness. Now, total happiness is made up of marginal utility. So marginal utility that's our increase in utility as I consume more of the product. So generally, almost always, I do become happier as I consume additional units of the product. The question really is how much happier do I become as I consume more of the product? That's what's captured by the marginal utility. So all that total utility represents then is it's the summation of my marginal utility. It's the summation of my marginal utility for all the products consumed. Now, we want to probably graph this out, and we're going to graph this out in a two-product space. So let's pick what the two products are going to be. It's always tough to do here. Let's say vitamins are going to be my product number 1. Product number 2. Let's make it keyboards, only because that's the thing that's right in front of me. Not a musical keyboard, a typing keyboard. That would be cool if it was a musical keyboard. Okay, so we're going to graph this out. So this is going to be quantity of vitamins. And over here, I'm going to put my quantity of keyboards. I could change this around if I wanted to. It doesn't have to be that this had to be here or that there. But the idea is that let's start plotting out bundles of the products. By bundles, I mean, imagine it like a basket that basically contains both of the products. What would we know? if I put a bundle way out here versus one here, which one would you want? You would probably want A over B. That bundle A is preferred to bundle B. Why? Because it has more of both goods. Let's throw one in the middle here. That bundle C is not preferred to bundle A. Because it has less of both goods, right? And I could have said the same for B as well, that bundle B is also not preferred to bundle A. So I have two notions of the kind of relationship that can exist. One where it's preferred and one where it's not preferred. And at this point, I don't need to know anything about how much people want certain things, because we know that if I have more of both products, I must absolutely be happier. And if I have less of both products, then I must be less happy. Okay. So now the question is, what about a product right here? Which brings up the question then, what is the relationship between C and D? You'll notice that if we were to compare bundles C and D, that D has more keyboards but fewer vitamins. So what's the relationship? There has to be some relationship between those two bundles. So let's just write this out here. D has more keyboards but fewer vitamins. So we've set up the problem now where you would need to know how much additional happiness I get from each product. Additional happiness from each product. That refers back to marginal utility. Right, so this is looking at additional happiness. What we need is an indifference curve. What an indifference curve does is it traces out all the bundles that generate the same level of total utility. Let's graph this out. I'm just going to keep this easy here. Quantity of vitamins, quantity of keyboards. And we already knew again the relationship between A and B and C. You can see they lie in a straight line when having more of them, each having more of both goods as we go to C and as we go to A. The question was how do we understand C and D? And what we could start to see are indifference curves. Indifference curves that most of the time look like this, that are curved inward. They kind of look like the man curves. They're not the man curves, but they kind of look like it. And again, each of these have a constant level of total utility. And as we move further to the right, the total utility is higher. So this would be U1, U2, U3, U4, U5, U6, U7. That U7 has the highest total utility. The relationship between C and D is that bundle C is indifferent to bundle D, meaning both make you equally happy. Now, we probably would want to know something then about what the slope of this curve is. The slope of the indifference curve is the ratio of the marginal utilities. Now there's a reason why that's the case. Because essentially along an indifference curve, the total utility is constant. Which means every time I have less of K, then I have less utility coming from K. But I have more vitamins, which means I have more utility coming from vitamins. And the two need to exactly offset each other, because that's what's going to keep the total utility constant. So, as I go along the graph, I have less of K, which means less utility coming from K, and I have more vitamins, which means more utility is coming from vitamins. The slope equals the marginal utility that's coming from vitamins over the marginal utility that's coming from keyboards. And it's negative because it's downward sloping. Now, another way to write this out would be it's the marginal utility of the good on the x-axis over the marginal utility of the good on the y-axis. This is the formal term that we have for this slope is the marginal rate of substitution. Or basically your willingness to substitute between the two products. Now, indifference curves can look different than this based on the relationship between the two goods. So what if I was talking about floss and toothpaste? Right? Understandably, if you're a good person at the dentist, right, you understandably buy toothpaste and floss in some sort of relationship, meaning in this case they are perfect complements. You're always supposed to brush your teeth, which now creates indifference curves that look like this, because we're saying only specific combinations of the two products make you happy. Alternatively, I could have perfect substitutes. Something like oranges and clementines. Like clementines are like small little baby oranges, essentially. Their indifference curves are straight lines. And once you have an understanding of what the relationship is between the two products, you can create even differently shaped indifference curves as well, with an understanding again of that marginal rate of substitution, or the slope of it, which is, again, is our negative ratio of the two marginal utilities. Now, we have to, this is only half of the way of understanding this. So let's end this part with our goal. Our goal at this point is to be on the highest indifference curve. In other words, be as happy as possible. Now, we need to find out the thing that's going to limit us or constrain us. What stops us from being at infinite happiness? And that would be our income and the prices we pay for things. So we need to add one more dimension to this graph. And we're going to do that with our budget constraint. So let's keep the same understanding of space here. Quantity of vitamins, quantity of keyboards. And let's say that a keyboard is $20. Let's say that vitamins cost $5. Right, so those are my two prices here. The price of my keyboards and the price of my vitamins. The other element we need here is we need to know what our income is. Let's say that our income is equal to $1,000. So, with that understanding, let's see here. With our understanding here, I'm just trying to figure out, I think there's a way I can do a calculator here. I don't think so, actually, never mind. We can do the math. I was going to try to do it where it pop up here, but let's not worry about that. We need to draw a budget constraint. And there is, unlike the indifference curves, there is only one budget constraint because we have only one income. The thing we need to do is we need to determine what the x-intercept is going to be and the y-intercept. The x-intercept, meaning where does the line intersect with the x-axis, that's going to be my income divided by the price of vitamins. Basically, it'd be a scenario where I did nothing but spent my money on vitamins. That would be 1,000 divided by 5. Which would mean that the most I could possibly, sorry, not dollars, the most I could buy would be 200 vitamins. Okay? Then I need to figure out my y-intercept, which is going to be my income divided by the price of keyboards. Which is going to be 1,000 divided by 20. Right, so now what we see here is that simply we need to connect the dots. The slope is the price ratio, or the price of vitamins over the price of keyboards, which in this case is 5/20. And it's negative because it's downward sloping. Now, we can alter this as well. We can alter this budget constraint as our income changes, which is what we'll do in number 6. But we're not doing that yet here. Because this now, number 2, basically ends with us now putting these two spaces together. Quantity of vitamins, quantity of keyboards, a series now of indifference curves. Again, goal being we want to be at the highest one possible, but something stops us. That something that stops us is our budget constraint. And you see here that if I draw this in a particular way, it's going to touch that curve at one point. Now you see here that it intersects U1 here, kind of intersects U1 here. We don't want to be doing that. We want to have the two slopes be equal. The goal, as restated here then, is the highest indifference curve that is just tangent to the budget constraint. In other words, touches the budget constraint only once. And we see that happening right here. This right here is our optimal choice, which is the thing that we started out, well, we ended with number one as part one of this as what our goal overall was, which was to find our optimal choice. This is our graphical understanding of our optimal choice. In number 4, we'll actually have a mathematical description of what this optimal choice looks like.